And the crazy part is, some of these deployments are happening hundreds, even thousands of times a day. We're talking Netflix deploying features while you're binge watching.
Thousands of times a day? That sounds insane. How do they even manage that without breaking everything? I mean, I've seen deployments take hours, and even then, they're prone to errors.
Exactly. And that's the problem we're tackling today. We're talking about CI/CD pipelines that don't suck. We're talking about getting from commit to production in ideally 10 minutes.
10 minutes? That sounds like a dream. Most teams I know are happy if they can deploy once a week without a major incident. What's the real cost of having these slow, unreliable pipelines? Is it just developer frustration?
Oh, it's way more than just developer frustration. Think about it. Slow pipelines mean slow feedback loops. If it takes hours to deploy a change, you're delaying the time it takes to get feedback from real users. That means you're potentially building the wrong thing for longer. And that delay translates directly into lost revenue, especially for companies that rely on rapid iteration, like e-commerce sites or social media platforms. Imagine Amazon having to wait half a day to fix a pricing bug during Black Friday.
Ouch, yeah, that's a lot of money. So, what are the key principles that make a CI CD pipeline not suck? What's the secret sauce?
Okay, let's break it down. First, automation, automation, automation. Obvious, right? But it's not just about automating the build and deploy process. It's about automating everything you possibly can. Think automated testing, unit tests, integration tests, end-to-end tests, and I mean comprehensive testing. The more you automate, the less you rely on manual intervention, and the faster and more reliable your pipeline becomes.
Okay, that makes sense. But how do you ensure those automated tests are actually catching the right things? I've seen plenty of pipelines where the tests pass, but then the deployment still breaks in production.
That's the million-dollar question. It's about building a robust testing pyramid. Think of it like this. At the bottom, you have tons of fast, isolated unit tests that verify individual components. Then, moving up, you have integration tests that check how those components interact with each other. And at the very top, you have a smaller number of end-to-end tests that simulate real user scenarios. Companies like Google are masters of this. They invest heavily in testing infrastructure and tooling to ensure their code is rock solid before it even hits production. They've even created custom tools for fuzzing and property-based testing.
So it's not just about having more tests, it's about having the right kind of tests at each level. Makes sense. What's next?
Next, we need to talk about infrastructure as code. This is where things get really interesting. Instead of manually configuring servers and networks, you define your entire infrastructure using code, things like Terraform or CloudFormation. This allows you to version control your infrastructure, automate its provisioning, and easily replicate your environments.
Okay, I see the benefit of version control for infrastructure, but doesn't that add a lot of complexity? Now you're managing both code and infrastructure as code. Is it worth the overhead?
Absolutely it is. Think about it this way. If you're managing your infrastructure manually, you're prone to human error. You might accidentally misconfigure a server or forget to update a security patch. With infrastructure as code, you can automate these tasks and ensure consistency across your environments. Plus, it enables you to spin up new environments for testing or development, which can dramatically speed up your development cycle. Uber uses infrastructure as code extensively to manage their massive fleet of servers and databases. They can spin up new regions in a matter of hours rather than days or weeks.
That's a compelling example. Okay, so we've got automation, a robust testing pyramid, and infrastructure as code. What's the third key principle?
The third one is small and frequent deployments. This is the real game changer. Instead of deploying large batches of code every few weeks, you deploy small, incremental changes multiple times a day. This reduces the risk of introducing major bugs and makes it much easier to identify and fix issues when they do occur.
But doesn't that increase the risk of introducing more bugs? If you're deploying more frequently, aren't you also increasing the chances of something going wrong?
That's where feature flags come in. Feature flags allow you to deploy code to production without actually exposing it to users. You can then enable the feature for a small subset of users to test it out and gather feedback before rolling it out to everyone. This gives you a safety net and allows you to iterate quickly without risking a major outage. Netflix is famous for this. They use feature flags extensively to test new features and personalize the user experience. They can even A/B test different versions of a feature simultaneously to see which one performs best.
Okay, feature flags are definitely a smart way to mitigate risk. So, small, frequent deployments, feature flags, makes sense. Now, here's where it gets interesting for me. Most engineers focus on optimizing the technical aspects of the pipeline, the build times, the test execution, the deployment scripts. But what about the human element? How do you get developers to actually use the pipeline effectively?
That's a great point, and it's something that's often overlooked. The best CI/CD pipeline in the world is useless if developers don't trust it or don't know how to use it properly. The key is to make the pipeline as easy and intuitive as possible to use. Think about it like this. If the pipeline is a black box, developers are less likely to trust it. They'll be more likely to bypass it or make changes directly in production, which defeats the whole purpose.
So, transparency is key. How do you make a pipeline more transparent?
Absolutely. You need to provide clear and concise feedback at every stage of the pipeline. Let them know what's happening, why it's happening, and what they need to do to fix any issues. Use clear and informative error messages. Provide dashboards and visualizations that show the status of the pipeline and the performance of your application. And most importantly, involve developers in the design and development of the pipeline itself. Let them contribute to the process and give them ownership of the system.
That makes a lot of sense. If developers feel like they're part of the process, they're more likely to buy into it and use it effectively. But what about the organizational culture? Doesn't that play a role as well?
Absolutely. A culture of collaboration and continuous improvement is essential for a successful CI/CD implementation. You need to create an environment where developers feel comfortable experimenting, taking risks, and learning from their mistakes. Encourage them to share their knowledge and best practices with each other. And most importantly, celebrate successes and learn from failures together.
So it's not just about the tools and technologies, it's about the people and the processes. Okay, I'm convinced. But let's get practical. What are three specific things a software engineer can do today to improve their CI/CD pipeline?
Okay, here are three actionable takeaways. First, start small and iterate. Don't try to build the perfect pipeline overnight. Begin by automating the most painful parts of your deployment process, and then gradually add more features and functionality. Think of it like building a house. You don't start with the roof, you start with the foundation.
That's good advice. What's number two?
Number two, invest in monitoring and alerting. You need to be able to detect and respond to issues quickly and efficiently. Set up alerts that notify you when something goes wrong in the pipeline or in production. Use monitoring tools to track the performance of your application and identify potential bottlenecks. Think of it like having a smoke alarm in your house. It won't prevent a fire, but it will alert you to it quickly so you can take action. Cloudflare is a great example of a company that invests heavily in monitoring and alerting. They have a sophisticated system that allows them to detect and mitigate attacks in real time.
Definitely crucial. And the third takeaway?
Third, and this is a big one, document everything. Create clear and concise documentation for your pipeline, including instructions on how to use it, how to troubleshoot common issues, and how to contribute to its development. Think of it like providing a user manual for your pipeline. It will help developers understand how it works and how to use it effectively.
Love it. So start small, invest in monitoring, and document everything. That's a great starting point.
Exactly. And remember, building a great CI/CD pipeline is not a one-time project. It's an ongoing process. You need to continuously monitor, improve, and adapt your pipeline to meet the changing needs of your business.
So it's about embracing the continuous in CI/CD, not just the integration and delivery.
Precisely. A CI/CD pipeline isn't a destination, it's a journey.
That's a great way to look at it.